Assalamualaikum to Dr. Muhammad Sa'ari Muhammad Isa. I am Muhammad Syamil Amirul bin Suhairi from Group 4, and our group will tell about budget optimization for satellite communication link using PSO and the Cuckoo's search algorithm. And this is all the name of Group 4, which is Nur Afiqah Safwana binti Muhammad Yunus, B0822100268, and myself Muhammad Syamil Amirul bin Suhairi, B0822100233, and Tarani anak perempuan Anathan, B0822100138. Next, I will talk about abstract. Due to the advancement of communication and information technology, satellite communication has become a crucial component of socio-economy development. It helps business and government organizations communicate in variety of ways. The range and reach of the communication satellite have grown even further because of progress and excellent design. The utilization of communication satellite is also used in power communication system to monitor and manage some electrical data acquisition system such as supervisory control and data acquisition SCADA and power link communication. This study purpose an efficient algorithm to compute the uplink and downlink frequency, transmitter and receiver antenna diameter, along with the antenna power and transmission efficiency, make up the link budget performance. The finding demonstrate the superior performance and efficiency of the Cuckoo search algorithm over PSO.
Since automation systems have advanced, control, monitoring, and remote operating are now seen as crucial elements of a modern system. As managed systems that keep an eye on a managed commercial operating occurring in the real world, SCADA offers remote operating in this regard. Next, SCADA applications currently in use and bandwidth needs are supplied by SATCOM. The most practical and economical alternative is IP communication, which has a 99.8% availability and is made possible by satellites. Then, the SATCOM link margin can be attempted to be reserved based on available information at fixed level. For transported SATCOM system, the power control algorithm is effectively built using the channel SNR data. After that, the process of distributing energy in the satellite transmission system. First, supplying a satellite transponder. Second, supplying a collection of widely spaced ground station. Third, signaling the local uplink locally. Third, receiving local signal at the indicated satellite. Fourth, gain constant amplification of the received uplink signal. Okay, I'll move to the next part, literature review. The transactions, the likelihood, accessibility, dependability, sensitive system analysis, and suggested course of action uses Laplace transform and Markov process theory. The suggested algorithm efficiently establishes transponded SATCOM links that satisfy the desired quality of service requirement. Then, wireless-based communication has gained a great deal of traction. To access remote network devices that are dispersed throughout the world, SCADA systems are used and satellite communication is the best option. By taking into account that straightforward architecture, a design for future carbon communication in satellite is suggested. The software is created to evaluate the purpose system viability.
Now, I would like to explain about the methodology of this research. In this research, we include different algorithms to find the best possible connection between the 2 points. One of the algorithm is called partial swarm optimization and the other is called Cuckoo search. The purpose of this article is to find the best way to use limited resources to send information between 2 points. By limiting the uplink parameters, downlink and the total carrier to noise ratio, we can calculate the transmit antenna power, transmit antenna diameter, uplink frequency, downlink frequency, the efficiency of the receiving antenna, and the diameter of the receiving antenna. Okay, the type of method used is carrier to noise ratio of transponder block, CN ratio of uplink station and downlink station, and CN ratio for overall station, partial swarm optimization, and cuckoo search algorithm. So from here we can see the first method is used is carrier to noise ratio of a transponder block, and there are three equations at 1, at 2 and at 3, and this three equation is formed to reduce the noise power ratio. The second one is CN ratio for uplink station. So the uplink equation are shown as below. The signal was transmitted as a noise-free uplink ground station, and the signal received on the satellite and first equation are known as Vn. The received uplink signal strength. Uplink noise satellite input is shown below, where the total bandwidth is shown. Carrier signals and noise signals are equal to Vn. Okay, from the equation 2, where the K is known as Boltzmann constant and the T set is saturated temperature. Number 3 is CN ratio for downlink station. Given that the satellite broadcasts a noise-free signal in the downlink, the received signal at the downlink Earth station is indicated in the equation 3, and the equation is known as downlink received signal power. The downlink Earth station noise level is seen below. As with the uplink station, the bandwidth of the carrier and noise signal is equal to Vn and is provided in equation 4 as downlink noise power. So for the CN ratio for the overall equation, here the evolution of the system overall CNA ratio is linked to the CNA ratio of the uplink and the downlink. The received signal at the satellite is depicted in equation 5, assuming that the uplink station signal sent to noise free. The satellite with a gain of G set amplifies the signal such that the sent signal by the satellite becomes as illustrated in equation 5, where the PTD is the power of the transmitter in the downlink. So the carrier to the noise ratio allows us to calculate system noise level. The overall noise level is lower than the noise level for each carrier to noise ratio. Comparison of two algorithm selection method, partial swarm optimization and cuckoo search, will be later presented in the next slide. Next one is particle swarm optimization. Using this approach, the error value should be reduced and the overall carrier frequency ratio increase in optimization. This algorithm is used to optimize link, carrier to noise ratio, uplink and downlink constraining parameters are used to evaluate performance. So, the flowchart of the PSO algorithm shows that the PSO initialization start for each particle and to update V to update X, and then evaluate Fx, and then satisfy termination criterion, and lastly solution is the best. Last one is cuckoo search algorithm. The cuckoo search method is introduced to improve SATCOM system performance and is utilized as an optimization tool to optimize performance in several industries, including business, communication, and so on. This approach may be used to retrieve and desired parameters more efficiently and the undesirable parameters less efficiently, but it also allows for the determination of the parameter optimal value. The carrier to noise ratio should be increased while the error value shouldn't be decreased. Both the link optimization and the performance metrics are assessed. So from the flow chart, we can understand when it starts, it initializing cuckoo search, determining fitness function, updating process operator to computing fitness, and then selecting operator, replacing operator, eliminating operator, and the final step is stop. Once if the process for updating position operator it does not support, it will start again from the first step.
Next, I will go through with result and discussion in these studies to determine which method offer the best optimization value. The two are compared and assessed. The range value are used to assess the design parameters which are then compared between two methods and the result. MATLAB is used in the simulation, and application is built using the same software. The table below is listed in the range. Table 1. Comparison between range of design parameters. Design parameters, which is uplink frequency, downlink frequency, earth transmit power, earth transmit and receive antenna efficiency, earth transmit and receive antenna diameter. The uplink frequency, the range is between 5.9 to 7 GHz. Downlink frequency is between 3.8 to 4.2 GHz. Earth transmit power is between 26 to 30 dB. And Earth transmit and receive antenna efficiency in between 50 to 70%. And the last one, Earth transmit and receive antenna diameter 2.5 to 4.5 meter. Then we go to the table 2, which is a comparison between PSO and cuckoo carrier to noise ratio. Both algorithm carrier to noise ratio are azimuth along with the overall satellite communication system, and the reference satellite model Telstar 5 for comparison purpose. The reference satellite model is given above. The carrier to noise ratio compile uplink, downlink, and total. The satellite Telstar 5 is uplink 105.7, and the PSO is 137.033, and the Cuckoo search is 150.601, and the downlink is for Tesla 5 is 85.4. The PSO is 117.81, and the Cuckoo search is 150.437, and the total for Tesla V is 84.5. The PSO is 170.759, and the Cuckoo search is 147.508. Table 3. The comparison between PSO and Cuckoo design parameters. Satellite communication link budget optimization using PSO and Cuckoo search algorithm 1461. After running the simulation for the design parameters, the comparison table shown is generated. This is all the table that comparison generate, which is uplink frequency, the range 5.9 to 7 GHz, and the PSO optimized value is 7 GHz, and Cuckoo search optimized value 6.85 GHz. The downlink frequency is 3.8 to 4.2 GHz, and PSO optimized value is 4.2 GHz, and the Cuckoo search optimized value is 4.16 GHz. The Earth transmit power, the range of 26 to 30 dB. PSO optimized value is 30 dB, and the Cuckoo search optimized value is 29.60 dB. Earth transmit antenna efficiency, the range of 50 to 70%, and the PSO optimized value is 70%, and the Cuckoo search optimized value 59.04%. The Earth receive antenna efficiency in the range of 50 to 70%. The PSO optimized value is 70%. The Cuckoo search optimized value is 64.90%. The Earth transmit antenna diameter in the range of between 2.5 to 4.5 meter, and the PSO optimized value is 4.5 meter, and the Cuckoo search optimized value is 2.57 meter. And the last one is Earth receive antenna diameter. The range is 2.5 to 4.5 meter, and the PSO optimized value is 4.5 meter, and the last one, Cuckoo search optimized value is 4.31 meter. This is all the result that we have.
Okay, now let's move to the conclusion. In this study, an effective technique was combined. The PSO and COCO search algorithm have been proposed for link maximization value in satellite communication. PSO needs improvement system performance. During the COCO hunting algorithm offer the best carrier to noise ratio of any ground station, including general satellite communication system. The evaluation results show that the COCO search algorithm is more efficient than PSO in terms of data transmission.